All right, good morning. Sorry I'm not there. One of my children has influenza A, so I am at home with him. Remember that your PINK formative assessment is due today. Make sure you turn that into the turn-in folder in the front of the room. And then today at the end of class, after this quick video, you will be getting not only a homework for tonight that will be due on Wednesday, but you'll also be getting the chapter review packet that will also be due on Wednesday. So you'll be getting a double homework this evening. Okay? Today what we're going to be doing is we are going to be using rational functions to solve application type problems. So word problems basically. Okay? So we're going to start with this one. It is on your sheet. First thing you're wanting to do on these problems is you're going to want to read these problems so that you know what you're looking for. A common misconception is that you can determine how far away lightning is by measuring the time between thunder and lightning. In reality, though, the time between seeing lightning and hearing thunder is a function of both distance and temperature. My grandma taught me how to do it, and it was you saw the flash of lightning, and then you counted seconds, and for every 5 seconds, that was a mile, because sound travels roughly at 1,100 feet per second. For you scientists in the room, okay, that's in ideal conditions is when lightning or sound travels that fast, and so then 5,280 feet would be a mile. 5 seconds would be roughly 5,500 feet. That's where they were going off of. Okay? But really, it's both distance, temperature, and really humidity too. Okay? So the time between seeing lightning and hearing thunder is represented by this function right here. Right here. I had to get my color. Okay? So time that you heard is equal to the distance it is away divided by 1.09 times t plus 1050. Okay, where d is the distance in feet between the observer and the lightning. T is the temperature. Oh, I said the t wrong. That's temperature. T is the temperature outside in Fahrenheit. Okay? So if the temperature outside is 70 degrees Fahrenheit, and you count 3 seconds between the thunder and the lightning, approximately how far away is the storm? Well, okay, you counted 3 seconds, so that's time. It's 70 degrees outside, that's temperature. Okay, so time was 3 seconds. I'm using that box formula right above there. That's going to be equal to the distance. We don't know the distance. That's what we're looking for. How far away is the storm? Okay. Times 1.09 times the temperature, which was 70, plus 1050. Okay, well, 1.09 times 70 is 76.3, plus 1050 is, so 3 here is going to equal d divided by 1126.3. To solve that, multiply both sides by 1126.3, and you get 3,378.9 feet is your distance. So that's going to be about 0.6 of a mile away. Okay? All right? If the temperature is now 80 degrees, and you estimate a half second between thunder and lightning, ooh, that's a pretty good bang to, or a flash to boom. So if you estimate half of a second, it's probably going to be pretty close to you. So this number that we get here at the end should be fairly small. How far away is the storm? Well, time was 0.5, 0.5. The distance is what we're looking for. 1.09 is going to be multiplied by 80 plus 1050. Okay. So 1.09 times 80 is going to equal 87.2 plus 1050 is going to equal, so this right here, I gotta get my colors right, so that's going to be 0.5 is going to equal D over 1137.2. So D is going to be 568.6 feet away. So almost 2 football fields away. That would get your heart going a little bit. Okay, for those of you that have been when lightning striked right above you, or when lightning's flashed right above you, I should say, or if it struck near you. Okay. On a 60-degree day, so that tells me my temperature. What is the time between thunder and lightning when the storm is directly overhead? Well, directly overhead means D is 0. Okay. So if we think about this, okay, we need to know what time is. Okay, time was purple for me. So time is going to equal, my distance was 0 over 1.09 times 60 plus 1050. Okay. I could do all that math, but if that storm is directly right over the top of my head, the time from flash to bang is going to be 0 seconds, because this is going to be 0 divided by some number, which is going to be 0. Okay? So it's flash and bang all at the same time. Now, on your homework tonight, if you tell me what thunder actually is, okay, if you use the Google and find what thunder actually is, I might throw a couple extra credit points your way. Okay. Problem number 2. Tracy and Adrian modeled the following problem with a rational function. Crunchy College Kids Snack Company manufactures a brand new brand of trail mix containing peanuts, almonds, and chocolate. Each package contains 400 grams of trail mix with 50% peanuts, 35% almonds, and 15% chocolat. Okay? Find the current number of grams for each ingredient of the 400-gram mixture is my first question. Okay. So, on that one, I've got 400 grams, 50% of which, so that's 0.50, is peanuts. So that tells me I've got 200 grams of peanuts. I've got 400 grams, and 35%, 0.35, is almonds. So that tells me that 140 grams are almonds. Let me move this. Give me a second here to move this stuff back over. So get a little more. Whoa. Don't want to move that. Okay. And then my last one. So I could either do 400 minus 200 minus 140, or I could do 400 times 0.15 is going to get me how much chocolate I have, which should be 60 grams. Okay. Herb loves himself some chocolate. When he gets his bag home, he wants to add it up. By the way, this problem B is on the back side of your note sheet. And you don't have to write this down. I'm not that mean, but it's on the back side of your note sheet. He wants to add enough chocolate so the mixture is 50% chocolate. Okay? So how much chocolate should he add? Okay. Well, right now, in his bag, we just found out when he walks out of the store, he's got 60 grams of chocolate in a 400 gram bag. Now, he's going to add chocolate to that bag. But if he adds chocolate to that bag, he's also adding grams to the total mixture. So he's adding X grams of chocolate, which is adding X grams to the total weight of that bag, and that then he wants to equal 50%, which is half of his bag. Okay? So we can do a little cross multiplication here, and we can say then that 400 plus X times 1 is going to equal 60 plus X times 2. These two and those two. Cross multiply. Okay? So on this side we get 400 plus X. On this side we get 120 plus 2X. And I want to solve for X. Okay? Well, if I subtract X from both sides, and at the same time I subtract 120, I get 280 grams is equal to X. So he's got to add 280 grams of chocolate. The kicker in this problem, ladies and gentlemen, is that you've got to add it to the top, which adds it to the bottom. Okay? In football, a quarterback's completion percentage is the ratio of the number of complete passes to the total pass attempts that he has. Okay? Current record holder for highest completion percentage is Chad Pennington, who completed 66% of his passes over the course of his career in the NFL. The quarterback in second place completed 3,843 passes out of 5,853 attempts. Estimate the number of consecutive complete passes the second place quarterback must throw in order to break the record. Show your calculations. Well, so if this second tier quarterback or the second place quarterback, right now he's sitting at 38.43 out of 58.53. He starts playing. He's got to complete some passes. But for each pass that he completes, that means that he's attempted another pass. And we want that to equal 66%, which in decimal form is 0.66. Again, I can cross multiply here because that's over 1. And so then I can go with 3843 plus x equals, that's this one, equals 0.66 times 5853 plus x. That's the second one in my cross. Crisscross applesauce. Okay. So that gives me 3843 plus x equals 3862.98 plus 0.66x, subtracting 0.66x, while at the same time subtracting 3,843, gets me 0.34x equals 19.98. Dividing both sides here now by 0.34. Gets me x equals 58.7647. Now, that's great. I get that on my calculator, but the problem is I can't complete this 0.7647 part of a pass, so he will need to complete 59 passes in a row. Okay. I've got to round up there. I can't round down because if I round down, I don't break the record. I'm still in second place. If I round up, I've broken the record. Okay? A saline solution of 120 milliliters contains 10% salt. How much water would need to be added to the solution for it to only contain 2% salt? Okay. Well, currently, the current salt content is 120 milliliters times 10%, okay, which is 12 milliliters of pure NaCl salt. Okay? So we've got 12 milliliters of salt in a 120 milliliter solution. Okay? I want to add pure water to that without any salt, so I'm just going to add water to the bottom here now because I'm not adding salt content, I'm just adding water to bring that solution down to 0.02% salt. Okay? These problems will take a little bit of logic in order to do them. Okay? That's over 1. Crisscross makes you want to jump. Okay? 12 there. And then 0.02 times 120 plus x will give me 12 equals 2.4 plus 0.02x, subtracting 2.4 from both sides, will give me, this up a little bit, 9.6 equals 0.02x. Divide both sides by 0.02. Gives me, I need to add 480 milliliters, capital L, of water to my solution in order to have only 2% of salt in that mixture. Okay? So you are going to get a cream a cream 7.5. Try it on your own. That will be due Wednesday, and you will also now be getting a Goldenrod Chapter 7 review assignment, and that will also be due on Wednesday. Hope you had a great weekend. Hope you enjoyed the video. We'll hopefully see you tomorrow in class.